In this video, we're going to look at polynomials. A polynomial is a sum of terms where each term is a product of a numerical coefficient and one or more variables with non-negative integer exponents. So here are some examples of terms that we might find in polynomials. In each of these cases, there's a numerical coefficient. This first term has a coefficient of 3. The second term here has a coefficient of -1. The third term here has a coefficient of +1. The next one here is a coefficient of 5. And the last term here is a constant term, and its coefficient is just -4. The variables in each of these have non-negative integer exponents. So they have to be positive whole numbers. This third one here has an exponent of 1. And if there's no variable, that can be thought of as having an exponent of 0, which would still be a non-negative integer. Remember, anything raised to the 0 power would be equal to 1. So -4 times x to the 0 is the same as -4. Here are some examples of terms that would not be terms we would find in a polynomial. In the first case, we have a variable with a square root. That's not the same thing as a variable that has a positive or a non-negative integer exponent. So we can't have square roots or cube roots or any other roots of the variables in a polynomial. We also cannot have negative integer exponents. That's equivalent to having the variable in the denominator. So these are considered terms because they're products of numbers and variables, but they're not terms that we can use in a polynomial. Here's an example of a polynomial in one variable. Notice we have a sum of terms, and each term has a coefficient and a variable raised to an exponent that is a non-negative integer, a positive whole number, or in the case of the constant term, we can think of this as having a variable with an exponent of 0, which, remember, would just equal 1. So we won't have to write that. There are no negative exponents, no square roots or cube roots, and no variables in the denominators. Remember, a polynomial is a sum of terms. That means the terms are added together. So if we have subtraction, that's really the same thing as a term with a negative coefficient. Here I've written this polynomial as a sum of each of these terms. That means I changed the subtraction to addition of the opposite. You will not have to rewrite the polynomials in this way, but it's important to be able to visualize it in this form so that you can clearly list the individual terms and their coefficients. This first term has a coefficient of +2. The second term has a coefficient of +4. The third term has a coefficient of -1. We get that from the subtraction. The fourth term here has a coefficient of +1, and the constant term, -7, has a coefficient of -7. Each term also has a degree, which is equal to the exponent on the variable, or if there's more than one variable, it's the sum of the exponents. So the first term has a degree of 5, the second term has a degree of 3, the third term has a degree of 2, this fourth term has a degree of 1. So when we don't see an exponent, the exponent's equal to 1, just like when we don't see a coefficient, the coefficient is equal to 1. 1 times x to the 1 power is equal to x. And the constant term always has a degree of 0. Remember, the constant term is equivalent to this number multiplied by x to the 0 power, because x to the 0 power is equal to 1. The exponent basically tells you how many times you're multiplying by that variable. So a 0 exponent means you're not multiplying by that variable at all. And that means a constant term will have a degree of 0 because it's not multiplied by any variables. Most of our polynomials will have one variable only, but if you do have a polynomial with multiple variables, then the degree of each term will be the sum of the exponents in that term. So this term has a degree equal to 3 plus 6, or 9. Here I've also demonstrated the standard way that a polynomial is written. It's usually written with the exponents in decreasing order. You should always check to make sure it's written in decreasing order. And if it's not, it's helpful to rewrite it in this form because it'll be easier to keep track of the terms, especially when we're working with multiple polynomials and trying to add or subtract like terms. It's also easier to see the degree of the polynomial as a whole when it's written in descending order. The degree of a polynomial is the largest degree of all of its terms. So in this polynomial, the degree is equal to 5, because that's the largest degree of each of these terms. So it's helpful to write it in decreasing order, and then we call this the leading term of the polynomial, the term with the highest exponent. We also define the leading coefficient of a polynomial to be the coefficient of the leading term. So in this case, the leading coefficient is equal to 2. So we get the degree of the polynomial and the leading coefficient from this leading term. Notice that we do not add all of the exponents in the polynomial to get the degree of the polynomial. We just get the exponent from the leading term. The reason the leading term is so important is because when you graph polynomial functions, the behavior of the graph is mostly determined by this leading term. So it's useful to classify polynomials by these leading terms, or by the degree. We have special names for polynomials that have just one term, or two terms, or three terms. A monomial is a polynomial with one term. So 3x, or just a constant term like 5, or a term with multiple variables. But notice there's no addition or subtraction. A term only has multiplication. So each of these is an example of a monomial. A binomial has two terms. For example, 15x minus 7, or x squared minus y squared. Each of these has two terms. And a trinomial has three terms. Here's an example of a trinomial with three terms. You do need to make sure that your polynomial is simplified before you can classify it as a monomial or a binomial or a trinomial. For example, here we have a polynomial. Each of these terms has a coefficient and a variable with a non-negative integer exponent, but we would want to simplify this expression and combine like terms before we identify the leading coefficient or the degree of this polynomial. We can see we have three x terms, 11x, 5x, and negative 1x. And these are like terms because the variable is the same and has the same exponent. Remember, when we combine like terms, we add the coefficients. So when we add the first two like terms here, 11x plus 5x, that gives us 16x. And then we're subtracting 1x from that. So 16x minus 1x leaves us with 15x. And we have two x squared terms. When we combine these like terms, we'll have 3x squared minus 7x squared, which is negative 4x squared. And now let's rewrite this with the exponents in decreasing order. So we'll want the negative 4x squared first, and then we'll add the positive 15x to that. Whenever you rearrange the terms in a polynomial, make sure you keep track of any subtraction or negatives and keep the negative with the corresponding term. Now we've simplified the original polynomial. We can see that we have a binomial, and we can state the degree and the leading coefficient of this polynomial. This polynomial has a degree of 2 because that's the largest degree of the two terms, and it has a leading coefficient of negative 4.